Hello and welcome to today's Tech Talk on how to reduce the cost of running compute-intensive workloads through high-performance file systems. Hi, my name is Daryl Osborne, and I'm a Principal Solutions Architect for File Storage here at AWS. The objectives in today's Tech Talk is to walk you through why you should consider moving to a fast parallel file system in the AWS cloud. You will get to know Amazon FSx for Lustre and how this service has been helping customers increase performance and reduce cost. Finally, we'll show how these opportunities can be addressed through a couple of demonstrations and to show how simple, fast, and cost-effective it is to run Amazon FSx and provide additional resources for getting started. Some of you may be asking, do I really need a fast parallel file system, and does it really matter? To effectively utilize high-performance processors, memory, and networking, and to avoid storage bottlenecks, these workloads typically depend on very high-performing file systems. These high-performing file systems reduce workload runtimes, accelerate business insights, and save cost by effectively and efficiently utilizing your compute resources, which account for the majority of these high-performance computing environments. Customers in many industries and applications process vast data sets to develop products and make business decisions. This is common in the financial sector, life sciences, and even in media and entertainment. And in the autonomous vehicles industry, EDA, and even in the oil and gas industry. You know, we see it widely used in big data and machine learning workloads. And for every dollar spent on high performance computing, businesses see $463 in incremental revenues and $44 in incremental profit. With these types of workloads, data is processed across large compute clusters or grids, and data is accessed through shared storage. A less than optimal storage layer selection can lead to bottlenecks that underutilize compute resources and lengthen runtimes. But if you select Amazon FSx for Lustre as your storage layer for these compute-intensive workloads, you avoid these bottlenecks, as Amazon FSx for Lustre provides up to hundreds of gigabytes of throughput, sub-millisecond latencies, and millions of IOPS. When we think about file system services here at AWS, we typically see them addressing two basic types of workloads. General purpose or business workloads for things like general purpose file sharing, user shares, application servers that need shared file storage. These, there are many business applications that require general purpose shared file systems, including, those used by corporate IT, even production facing websites. These really range from internal corporate users using a productivity app that requires shared file storage to a large number of external users accessing things like a CRM application for loan documents or medical records, or even e-discovery software. For those Linux-based workloads, we have Amazon Elastic File System or Amazon EFS. And for Windows-based workloads, we have Amazon FSx for Windows File Server. The other type of workload we typically see is high-performance workloads, requiring hundreds of gigabytes of throughput, sub-millisecond latencies, and millions of IOPS. We see this in a lot of different types of applications, like media rendering. Oil and gas seismic industry uses a lot of these high-performing file systems. Genome analysis, grid computing, even data lake storage, machine learning, deep learning. As you can tell, there's a lot of great opportunities to use Amazon FSx with these types of workloads. Customers use Amazon FSx to make compute-intensive workloads simple, cost-effective, and fast. It's simple because it's providing native integration with Amazon S3, providing a POSIX file system for S3 objects. And because it's fully managed, you don't have to perform software updates and hardware maintenance. It's fast, providing hundreds of gigabytes per second throughput, millions of IOPS, and sub-millisecond latencies. And it's cost effective, giving you flexible data processing options for short or long-term workloads, that works on a wide range of performance levels, giving you the ability to quickly spin up and spin down these high-performing parallel file systems on demand. And as you can see, these are all cost-effective ways to simplify using file storage on AWS. We do see customers struggle with the decision on how to effectively process data stored in S3 using compute instances. Typically, we see them address this challenge in one of three ways. Copy data sets to EC2 instances or EBS volumes attached to EC2 instances. Copying data sets into a self-managed file system, so multiple instances can access the same data. Or process data directly in Amazon S3 using gets and puts from your application. Doing any of these with a regular compute workload is pretty straightforward, but you have to really take into account, tuning, provisioning, and support, and the overall management and maintenance of this entire environment. Now, when you add the requirement of putting in a high-performance file system for a high-performance workload, you have to manage the striping, the storage servers, the metadata servers, and balancing and tuning that really comes with effectively using this environment. So you can see quickly it really becomes a headache, and it can really drag on productivity and impact your ROI and TCO. Amazon FSx for Lustre is designed for these types of data processing workflow. And it's pretty simple in terms of how it works. You connect to your S3 bucket. Amazon FSx for Lustre will instantly load the metadata of that S3 bucket and then begin to transfer those files from S3 to your file system in a very fast rate. However, it also prioritizes any files identified by your application for work. So it instantly prioritizes and uploads those immediately. It basically lazy loads the data into your file system. What you get up and running, but you really get up and running very quickly and right away. There may be a few second latency upon first access of a file that hasn't been already loaded into Amazon FSx for Lustre, but once it's there, you get high throughput and sub-millisecond latencies. Also, when you grab those files from S3, we keep the POSIX permissions, which you can see it is very important. So information like the permissions associated with it, the owner, the user owner, the group owner. All of this information is brought in with that file, so your application can perform as expected. Now let's go ahead and see exactly how simple and easy it is to get started with Amazon FSx for Lustre with the S3 integration. So the first thing I want to do is actually go ahead and create a new file system. So in the Amazon FSx console, we select Create File System, and then select Amazon FSx for Lustre. From here, you can go ahead and just type in an optional name for your file system. This isn't used to access the file system, it's just a key value pair. So I'm just going to go ahead and type in demo. Next is the deployment type, either persistent or scratch. I'm going to use a persistent file system today. The storage capacity, I'm going to use a very small file system, so it's only going to be 2.4 terabytes. The throughput capacity per unit of storage is going to be 50 megabytes per second, but I have the ability to select either 100 megabytes per second per terabyte or 200 megabytes per second per terabyte. I'll go ahead and just select the 50 for now. So my baseline throughput capacity for this file system is going to be 117 megabytes per second. Next, I go ahead and select the network and security parameters or configuration for my file system, the VPC, where my file system will reside, the security group that will be attached to my file system, and then the subnet. So I'm going to go ahead and select subnet in US East 1A. I'll go ahead and accept the default encryption. It uses AWS KMS, which manages the keys used to encrypt the data at rest. Next is the data repository integration. This is really where I want to focus my time on. We'll go ahead and select Amazon S3 as the data repository. And I'm going to go ahead and select a bucket that I have created. It's US West 2, NASA, and EX. So this is a data set that NASA, that has some of the NASA data in it. And what's going to happen is when my file system gets created, it's going to look at all of the objects in this bucket, and it will create the metadata of all these objects in my file system. So when my file system launches and is available, I'll be able to take a look at all of those files, which were actually objects in the S3 bucket. So that's my import bucket. The export bucket, what I'm going to do is select this second option here. It says the same prefix that you imported from. So basically what I'm going to do is when I export data from my FSX for Lustre file system to S3, it's going to go in the exact same path as the data that was imported in. So what that means is it will basically just create a new version because I have versioning enabled on my bucket. It will create a new version of that object when I export it back to S3. After that, we can go ahead and select the maintenance window of when that maintenance, weekly maintenance is going to be performed on that file system. If in the event that maintenance is needed that week, so we don't perform maintenance every week, but in the event that an emergency or a critical patch is needed, we would go ahead and take advantage of that 30-minute window that you define here, or you could update it after the file system has been created to perform that maintenance. If there are any additional tags you want to associate with your file system, you can do that here as well. Go ahead and select next. And here I can review all the different options that I selected, and I'll go ahead and create file system. I already have one created, so I'm not going to create this one. I've got this one created earlier. It's the exact same configuration as I just walked through, 50 megabytes per second, a 2.4 terabyte file system, a total throughput of 117 megabytes per second, and the data repository is associated with that US West 2 NASA NEX S3 bucket. So I do have an EC2 instance that I have here. You notice this instance just has two different windows. I'll go ahead and use the bottom window, and we'll take a look at the file system that has been mounted. So we see that we do have one of my Lustre file systems mounted. And it is mounted as /FSX. So if I go to my /FSX directory and do a simple ls against it, we can see all the different directories that we have there. So what I can do is let's hop over to my console, and here we can go to the S3 console. And here is that S3 bucket that I associated with my file system. So again, you can see all the different directories in the file system are also available as here within my S3 bucket. If we go ahead and click on this file system or this folder, we can scroll in and actually drill down into Common Grid. I think Access 1 is a file that I'm going to get access to, RCP45. And yeah, so I think we've got a file in here. So here's a file that I think we're going to go ahead and use today. So as you can see, this file is somewhat down sort of the path. You know, you may be familiar with Amazon S3. It's an object storage. There is no hierarchy, so this is basically just the prefix of the file. But we can think of it as a hierarchy within the FSX for Lustre file system. So now that we sort of have an idea of what this path is, we can go back to our FSX file system, and we can go into that directory basically. And here we'll go into Common Grid. And I think we needed to get into Access. I think that was the directory. Let's just go back and make sure. Access 1. Then RCP45. And then we'll go into, and then this directory. All right, so we can see here's that file that we saw within the S3 bucket. So this object here is basically this file within the file system. But if I do a simple LFS-DF-H against the file system, we can actually see that this is the configuration of the file system. I have a metadata target. Then I have 2 object storage targets. So we can see the data used very small, about 4 megabytes in each. But when we take a look at this file, let me just go ahead and grab that file. I'm going to store it as just a variable, and we'll do a simple ls against that file. So here is the, I just copied that file path into a variable. And if we go ahead and take a look at do a simple ls against that file, we can see that we see all the permissions and the username and the group that owns that file. It's a 200 megabyte file. And so what we're going to do is we're going to go ahead and take a look at the state of that file. You notice that, I mean, for all purposes, it looks like that file exists. But if we take a look at the state, the LFS HSM state of that file, we basically see these words: released, exists, and archived. So what that means, released, is that it's released from the file system. It's actually the data portion of the file does not reside in the file system, but it exists in the archive, meaning that that object is stored in S3, but the object data doesn't reside in the FSX for Lustre file system yet. So what we want to do, up here, I'm going to go ahead and run nload. Nload is going to monitor in real time the network traffic to this EC2 instance. So the first thing I want to do is just go ahead and do a simple cat or read this file into the memory of this EC2 instance, into the shared memory of this instance. So I'm going to go ahead and kick this off. What I want you to do is take a look at the top portion of my screen and look at the real-time traffic of this instance. And you noticed I kicked it off, so we're going to wait a few seconds here. You see no network traffic happening yet. Then right at the end, we're going to see some activity. So it took about 6.104 seconds in order to read that 218 megabyte file from FSX for Lustre to this instance. So you may think that, hey, that took a long time. But if we go ahead and kick it off again, it's going to be very fast. And some of you may be thinking, well, I'm actually just reading. We didn't see any network performance, so it didn't read it over the network. I'm just reading from memory. And you're right. We're actually just rereading that memory from the cache into the shared memory. So what we want to do is let's go ahead and drop our cache. So the next time we do this read, it's actually going to be from the FSX for Lustre file system. And now this time, because that file wasn't, the data portion of that file didn't exist in the FSX for Lustre file system, it only existed in S3. The latency that you saw was basically FSX transparently and automatically going out to S3, issuing a get operation, and getting that file, storing it in the FSX for Lustre file system, and then delivering it to this client. So now when I go ahead and run this cat again, it's going to be direct, it's going to be reading it right from FSX for Lustre because the data already exists in FSX for Lustre now. So you notice it's going to be much faster. Basically, 507 milliseconds to read that 218 megabyte file. So much faster than the 6 seconds it took on that initial read operation, because the data portion of that file already exists in Amazon FSX for now. So what we can do is we can validate that, and we can take a look at the HSM state of that file. You notice before it said released, exist, archive. You notice it doesn't say released anymore. It just exists and archived. So now we know that that data actually exists now within the file system. It's not released. And what we can do is we can take a look at where that file is simply by saying, hey, now that we can see that the file is actually stored on OST 0. Because we just added about 118 megabytes to this OST. Now, what we can do is simply release this file, issue an HSM release. And what we're going to do here is we're going to release the data portion of this file. Now, if we run an HSM state against it, we're going to see that it's released, exists in archive. And if we go back and do a df-h against that file system, we'll see that now that data portion has been released, but the file still exists. So if we do an ls against it, we still see that file. It, for all practical purposes, the file system still thinks that file is there, and it is there. Just the data portion hasn't been loaded into FSX for Lustre. So upon next access, if we go ahead and see if we can cat that file again, you're going to see a higher latency because, again, FSX for Lustre is going to have to go out to S3, get that object, store it in FSX for Lustre, and then deliver it to this client. You notice that the latency here, the delay, and now the file is going to be delivered to the client from FSX for Lustre. Great, so let's go back to the slides. So oftentimes we see customers coming to us and say, you know what, we would like to have a certain amount of storage capacity for us. And in this example, maybe they're asking us for 80 terabytes or tebibytes of storage. The great functionality or feature of FSX for Lustre is that we're able to offer to that customer multiple or different performance levels. They can have that file system, that 80 terabytes of file system, in either 50 megabytes per second per tebibyte, 100 megabytes per second per tebibyte, or 200 megabytes per second per tebibyte of storage performance. So it really allows you to select the performance level that you need for your workload. We can also have customers that come to us and say, you know what, I need a certain level of performance. Either, you know, in this example, 4 gigabytes per second. So in that case, you would create a file system size based on the performance that you need, based on those metrics of 50 megabytes per second per tebibyte, 100 or 200. So in this case, you would just create a file system large enough to support the 4 gigabytes per second throughput that you need for this file system. You also have up to 1.3 gigabytes per second burst throughput of these file system for short periods of time, which really allows you to for these applications and these workloads to burst far above the baseline throughput that you select when you create the file system. So let's do another quick demo. And this demo is going to be around the latency of the file system. My second demo is a read latency test using FIO with a 4 kilobyte block size for 10 seconds. So here we'll be able to take a look at the latency of this file system. And as we can see, really the most important statistics or the measurement that we want to take a look at here is the CLAT, or the completion latency. Which is really the time that passes between the submission of the kernel and when the IO is complete. And here we can see that the 99.95 percentile is under a millisecond, basically 889 microseconds. So again, very low latency, again, reading from this file system. So these performance levels allow you to optimize your storage costs and performance. Really, here you have access to both scratch and persistent deployment type file systems. Now with the new HDD storage type, selecting a persistent file system really gives you the flexibility to select the baseline throughput that you need. Either 50 megabytes per second per tebibyte, 100 megabytes per second per tebibyte, or 200 megabytes per second per tebibyte for the SSD storage. And either 12 megabytes per second per tebibyte or 40 megabytes per second per tebibyte for the HDD storage type. You know, prices range from really 14 cents to 29 cents per gigabyte a month for the SSD storage. And it can go as low as you can see here with the 50 megabytes per second per terabyte of 14 cents per gigabyte a month for the SSD storage. Keep in mind though that you have instances in different AZs, if you have instances in different AZs, that your FSX for Lustre file system, when it's accessed from those instances, may incur inter-AZ data transfer costs. But keep in mind that even for your short-term workloads, these scratch file systems really have half the price as the persistent file systems, as you can see here with the 200 megabytes per second per terabyte persistent SSD file system. Earlier, I ran a write IOR test against the same 2.4 terabyte file system that has a 50 megabytes per second per terabyte throughput capacity. And I sped up the video just for the sake of time. And as we can see with this video, I was able to achieve 604 megabytes per second throughput burst for a short period of time, followed by a baseline, very consistent 149 megabytes per second against this file system. And this is write activity against a 2.4 terabyte file system, which has a baseline throughput of 117 megabytes per second. My second test was a read IOR test. And again, I recorded it earlier and I'm speeding it up for the sake of time. Here we can see that for a short period of time, I was able to burst up to 638 megabytes per second throughput, followed by a very consistent baseline read performance of 153 megabytes per second throughput. My final test is really a test of the network performance of my file servers. So in this test, I'm doing a read operation against a data set that can fit within the in-memory cache of the file system. So again, here I was able to achieve 3,170 megabytes per second throughput for a short period of time, and that was the burst performance of the file system. And basically what I was doing was just testing the network performance of this file system by reading only within the memory cache. That was followed by a very consistent 625 megabytes per second baseline throughput for this test. FSx for Lustre is optimized to reduce the cost of compute-intensive workloads found in a wide spectrum of use cases. For example, in life sciences, we have Blackthorn. For media and entertainment, we have Hive and Conductor. And for autonomous vehicles, we have Toyota. And for SaaS grid or these grid computing environments, we have T-Mobile. FSx for Lustre is also popular in the financial services, in oil and gas, in the semiconductor or EDA workspace as well. We have, machine learning use cases, HPC using parallel cluster that Maxar uses. And let me give you an example with Hive. So Hive Visual Effects has built this studio that really is designed for collaborating exclusively with a hub of freelancers using EC2, ThinkBox, FSx for Lustre, as well as S3. And the founder of Hive, Bernie Kimbacher, said this: I can spin up an Amazon FSx for Lustre file system in 5 minutes, and it's all managed by AWS. I don't have to worry about the nodes in the background that are running or the multiple network connections that are happening. All of it is managed for me. Toyota, which uses FSx for Lustre for their autonomous vehicle and machine learning training jobs, said this about FSx for Lustre: the integration with AWS services, including S3, also made it the preferred option for a high-performance file storage. Maxar Technologies delivers Earth intelligence and space infrastructure and currently has more than 90 geocommunication satellites in orbit and 5 robot arms on Mars. The company collects data across more than 3 million square kilometers of satellite imagery per day and has an archive of over 110 petabytes of satellite images, basically scanning the globe. So when using AWS, they're able to generate weather forecasts 58% faster, which provides clients more time to react to extreme weather conditions. They're also able to reduce the required server instances by 33%. And they were automatically able to spin up 156 server instances up and down very quickly, which reduced their overall compute costs by 45%. So here's a quick recap of the core areas we covered around how simple it is to launch and run FSx for Lustre. We covered performance benefits around the super low latencies, high throughput that you can achieve, as well as ways to optimize your cost. FSx for Lustre provides persistent shared storage for multiple, really up to thousands and thousands of concurrent instances. It has sub-millisecond latencies, millions of IOPS, and hundreds of gigabytes per second throughput. It's easy to spin up and tear down. The scratch file storage file systems really save costs for those short-lived file systems. And the Amazon S3 integration really reduces latencies and repeat request costs, charges that you could incur if you repeatedly accessed S3 objects. Data stored in S3, you can without rewriting to your file-based application. So you can store your data in S3, but you don't have to rewrite or re-architect your application, because now you can use FSx for Lustre, which is a POSIX compliant file system that many applications can just start to use right out of the gate. So in summary, high performance storage really saves in development costs, compute costs, and storage costs. Additional information can be found on the resources tab of our FSx for Lustre product page. And here you'll have access to lots of our videos, blogs, labs, some of our FAQs, our best practices, and even some of our customer references. So with that, we'll have some time for some Q&A.